Hello students, in this video we will do miscellaneous exercise 5. Now in first question we have to find the value of I raised to power 18 plus 1 upon I raised to power 25 whole cube. Now this I raised to power 18 can be written as I square raised to power 9 plus, and this 1 upon I raised to power 25 can be written as 1 upon I into I raised to power 24. Now, this I raised to power 24 will be equal to I square raised to power 12. As I square is equal to minus 1, so this will be equal to minus 1 raised to power 9 plus 1 upon I into minus 1 raised to power 12 whole cube. Now, minus 1 raised to power 9 will be equal to minus 1 plus, now minus 1 raised to power 12 will be equal to 1, and thus this will be equal to plus 1 upon I whole cube. Now that will be equal to minus 1 plus, now 1 upon I, we can rationalize it by multiplying the numerator and denominator by I, and that will give us minus 1 plus I upon I square. Again, on putting the value of I square as minus 1, this will be equal to minus 1 minus I whole cube. Now minus 1 minus I whole cube will be equal to minus 1 cube plus 3 minus 1 square into minus I plus 3 minus 1 into minus I square plus minus I cube by the formula of A plus B whole cube, and that is equal to A cube plus 3 A square B plus 3 AB square plus B cube. Now minus 1 cube will be equal to minus 1. Now minus 1 square will be equal to 1, and this I square minus I square can be written as I square, and minus I cube will be equal to minus I cube. Now here, as we know, my I square is equal to minus 1 and I cube will be equal to minus I. So this will be equal to minus 1 minus 3I minus 3 into minus 1 minus, and I cube is equal to minus I, and that will give us the value as 2 minus 2I. Now in question number 2, we have to find out that real Z1 Z2 is equal to real Z1 into real Z2 minus imaginary Z1 into imaginary Z2. Now let Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. So Z1 into Z2 will be equal to x1 plus iy1 into x2 plus iy2, and that will be equal to x1 x2 plus I x1 y2 plus I x2 y1 plus I square y1 y2, and I square is equal to minus 1, so that will be equal to x1 x2 plus I into x1 x2 plus x2 y1 minus y1 y2, and this can be written as x1 x2 minus y1 y2 plus I x1 y2 plus x2 y1. So here real part of z1 z2 is equal to x1 x2 minus y1 y2, and x1 is real part of z1, x2 is real part of z2, y1 is imaginary part of z1, and y2 is imaginary part of z2. This we have to prove. Now in question number 4, x minus iy is equal to under root a minus ib upon c minus id is given to us, and we have to prove that x square plus y square whole square is equal to a square plus b square upon c square plus d square. Now for that, first of all, x minus iy is given to us, so we will find out the value of x plus iy, and that will be equal to a plus ib upon c plus id. We will change the sign of imaginary part here. So multiple of x minus iy into x plus iy will be equal to root of a minus ib upon c minus id into a plus ib upon c minus id, and which will be equal to root of now x minus iy into x minus x plus iy will be x square minus I square y square, and that will be equal to a minus ib into a plus ib upon c minus id into c plus id, which will be equal to a square minus I square b square upon c square minus I square d square. As we know, I square is equal to minus 1. So this will give us x square plus y square equal to root of a square plus b square upon c square plus d square. And on squaring both sides, it will be x square plus y square whole square equal to a square plus b square upon c square plus d square, which we had to prove. Now in question number 10, Z1 is equal to 2 minus I and Z2 is equal to 1 plus I. We have to find the value of modulus of Z1 plus Z2 plus 1 upon Z1 minus Z2 plus 1. Now Z1 plus Z2 plus 1 upon Z1 minus Z2 plus 1 will be equal to 2 minus I plus 1 plus I plus 1 upon 2 minus I minus 1 plus I plus 1, and that will be equal to 2 minus I plus 1 plus I plus 1 upon 2 minus I minus 1 minus I plus 1. Here minus I plus I will cancel out, and minus 1 will cancel out with 1, and this will give us 4 upon 2 minus 2i. Now 2 minus 2i can be written as 2 into 1 minus I, and that will give us 2 upon 1 minus I and we can rationalize it by multiplying the numerator and denominator by 1 plus I, and that will be equal to 2 into 1 plus I upon 1 square minus I square, and minus I square can be written as minus 1, which on solving is giving us the answer as 1 plus I. So the value of Z1 plus Z2 plus 1 upon Z1 minus Z2 plus 1 is 1 plus I, and so modulus of its modulus will be equal to modulus of 1 plus I, and that is equal to root of 1 square plus 1 square, and that will be root 2. Now in question number 7, a plus ib is given to us as a x plus I whole square upon 2x square plus 1, and we have to prove that a square plus b square is equal to x square plus 1 whole square upon 2x square plus 1 whole square. Now as a plus ib is given to us as x plus I whole square upon 2x square plus 1, so we can find its conjugate, that is a minus ib, by changing the sign of the imaginary part, and that will be x minus I whole square upon 2x square plus 1. Now we have to keep in mind we have to change the sign of only imaginary part. That means this I will be equal to minus I. Now multiple of a plus b and a minus b will be equal to x minus I whole square upon 2x square plus 1 into x minus I whole square upon 2x square plus 1, and this will give us a square minus I square b square equal to x plus I into x minus I whole square upon 2x square plus 1 whole square, as I square is equal to minus 1. So this will be equal to a square plus b square equal to x square minus I square whole square upon 2x square plus 1 whole square, and that will be equal to x square plus 1 whole square upon 2x square plus 1 whole square, which we had to prove. Now in question number 12, Z1 and Z2 are given to us, and we have to find the value of real Z1 into Z2 upon conjugate of Z1. Now Z1 into Z2 upon conjugate of Z1 will be equal to 2 minus I into minus 2 plus I upon conjugate of Z1, and conjugate of Z1 will be equal to 2 plus I. Now this 2 minus I into minus 2 plus I will be equal to minus 4 plus 4i minus I square, and that will be equal to minus 1 upon 2 plus I, which on solving is giving us the value of z1 z2 upon mod of z1, or you can say conjugate of z1 as minus 3 plus 4i upon 2 plus I, which can be rationalized by multiplying the numerator and denominator by 2 minus I, and that will be minus 6 plus 3i plus 8i minus 4i square upon 4 plus 4 minus I square. As you know, I square is equal to minus 1. So this will be equal to minus 6 plus 11i minus 4 into minus 1 upon 4 into minus 4 minus minus 1. And that on solving will give us z1 z2 upon conjugate of z1 as minus 2 upon 5 plus 11 upon 5i, and here real part of z1 z2 upon conjugate of z1 will be equal to minus 2 upon 5. Now in question number 14, x minus iy into 3 minus 5i is equal to the conjugate of minus 6 minus 24i, and here we have to find the value of x and y. So x minus iy into 3 plus 5i will be equal to conjugate of minus 6 minus 24i. Now x minus iy into 3 plus 5i will be equal to 3x plus 5xi plus 3yi plus minus I square 5y, and conjugate of minus 6 minus 24i will be equal to minus 6 plus 24i, and this will give us 3x plus 5x minus 3y into I plus 5y as I square equal to minus 1 equal to minus 6 plus 24i. Now on separating the real and imaginary part, the left hand side will be 3x plus 5y plus 5x minus 3y into I, and that equal to minus 6 plus 24i. On equating the real part and imaginary part, 3x plus 5y will be equal to minus 6 and 5x minus 3y will be equal to 24, which can be solved by elimination method, and that is giving the value of x as 3 and y as minus 3. Thus we can say that x is equal to 3 and y is equal to minus 3. Now in question number 15, we have to find the modulus of 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I. So first of all, we will find out the value of 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I, and that will be equal to 1 plus I square minus 1 minus I whole square upon 1 minus I into 1 plus I, and that will be equal to 1 plus 2i plus I square minus 1 minus 2i plus I square, and that will give us 1 plus 2i plus I square minus 1 plus 2i minus I square upon 1 minus, and I square will be equal to minus 1, 1 minus minus 1. Now this here I square minus I square will cancel out, minus n plus 1 will be equal to 0, and 2i plus 2i will be equal to 4y, 4i and 1 plus 1 will be equal to 2, and that will be equal to 2y. Now, so modulus of 1 plus I minus 1 minus I upon 1 plus I will be equal to modulus of 2I. Now here the imaginary part, real part is 0, so that will be equal to root of 0 square plus 2 square of imaginary part, and that is 2 square, and that will be equal to 2. Now in question number 16, x minus iy whole cube is equal to u plus iv is given to us, and we have to find out the value of u upon x plus v upon y. As we know that a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. So this x plus iy whole cube will be equal to x cube plus 3x square into iy plus 3x into iy whole square plus iy whole cube, and that is equal to u plus iv. Now x cube plus 3x square iy plus 3xy square I square plus I cube y cube will be equal to u plus iv. As we know that I square is equal to minus 1, so this plus 3xy square I square will be equal to minus 3xy square, and I cube is equal to I, so I cube is equal to minus I, so this I cube y cube will be equal to minus I y cube. Now on separating the real and imaginary parts, we will get x cube minus 3x cube minus 3x y square plus 3x square y minus y cube I equal to u plus iv. Now on equating real and imaginary part, u will be equal to x cube minus 3xy square and v will be equal to 3x square y minus y cube. Now we have to find out the value of u upon x plus v upon y. So it will be equal to x cube minus 3xy square upon x plus v upon y will be 3x square y minus y cube upon y. Here on taking x as common, x will cancel out. Here we will take y as common and that will cancel out. And this will give us x square minus 3y square plus 3x square minus 4y square, which will be equal to 4x square minus y square, and that can be written as 4 into x square minus y square. Now in question number 17th, we have to find out the modulus of beta minus alpha upon 1 minus conjugate of alpha into beta, where alpha and beta are complex number and modulus of beta is equal to 1. As we know that the modulus of a complex number or square of the modulus of a complex number is equal to the complex number into its conjugate. So we can say that the modulus of beta minus alpha upon 1 minus conjugate of beta alpha into beta whole square will be equal to beta minus alpha upon 1 minus conjugate of alpha into beta into its conjugate. That means beta conjugate minus alpha conjugate upon 1 minus conjugate of alpha conjugate, that will be alpha into beta conjugate, and this will be equal to beta into conjugate of beta minus beta into alpha conjugate minus alpha into beta conjugate minus alpha into alpha conjugate upon 1 minus alpha beta conjugate minus alpha conjugate beta minus alpha alpha conjugate and beta beta conjugate. Now as we know that a complex number into its conjugate is equal to its square of its modulus, so we can say that beta into beta conjugate will be square of modulus of beta minus alpha conjugate beta minus alpha beta conjugate minus alpha into conjugate of alpha will be equal to modulus of alpha square. Now upon 1 minus alpha beta conjugate minus alpha conjugate beta minus alpha into alpha conjugate will be square of modulus of alpha, and beta into beta conjugate will be square of modulus of beta, and that will be equal to 1 minus, as modulus of beta is 1, so square of modulus beta will be equal to 1, so that will be equal to 1 minus alpha conjugate beta minus alpha beta conjugate minus conjugate of alpha square upon 1 minus alpha conjugate beta minus alpha beta conjugate minus modulus of alpha square into modulus of beta square, that was equal to 1, and this will give us 1 as numerator and denominator are same. Now in question number 18, modulus of 1 minus I raised to power x is equal to 2 raised to power x is given to us, and we have to find the value of x. Here modulus of 1 minus I will be equal to root of 1 square, that is real square of real part, plus a square of imaginary part, that is minus 1 here, raised to power x equal to 2 raised to power x, and that will be root 2 raised to power x equal to 2 raised to power x. Now root 2 raised to power x can be written as 2 raised to power x by 2, and that will be equal to 2 raised to power x. Now as base is same on left hand side and right hand side, so their powers will be equal, and that means x upon 2 will be equal to x, and that will give us 2x minus x equal to 0, which is giving us the value of x as 0. Now in question number 19, a plus ib into c minus id into e minus if into g minus ih is equal to a plus ib is given to us, and we have to find out the value of a square plus b square. So first of all, we will find out the conjugate of a plus ib, that is a minus ib, and that will be equal to a minus ib into c minus id into e minus if into g minus ih. Now multiplying equation first and second, now a plus ib into a minus ib will be equal to a square minus I square b square. C minus id into c plus id will be equal to c square minus I square d square. E plus if upon e minus if into e minus if will be e square minus I square f square, and g minus ih into g plus ih will be equal to g square minus I square h square, and that will be equal to a plus ib into a minus ib, and that will be a square minus I square b square. As I square is equal to 1, so our left hand side will be a square plus b square into c square plus d square into e square plus f square into g square plus h square, and that will be equal to a square plus b square. Now in question number 20, 1 plus I upon 1 minus I raised to power m is equal to 1. This is given to us. We have to find the value of m. Now, first of all, we will rationalize 1 plus I upon 1 minus I by multiplying its numerator and denominator by 1 plus I, and that will give us 1 plus 2I plus I square upon 1 minus I square raised to power m is equal to 1. Now as I square is equal to 1, so we will get 1 plus 2I minus 1 upon 1 minus 1 raised to power m equal to 1, and that will give us 2I upon 2 raised to power m equal to 1, which will be equal to I raised to power m is equal to 1. As I raised to power 4 is equal to 1, so in place of 1 we can write I raised to power 4, as base on both the sides is equal to I, so their powers will be equal. So we can say that m is equal to 4. Thank you.